minutes, how good it is.
Brilliant.
Yeah,
brilliant.
I think if you're not familiar with Ian, so Ian Nixon said he sits in a PTAG council member. He's been involved in swimming pools for a number of years, shall we just say, and leave it at that.
51.
51 years, yeah. I have long discussions with him on different topics on pools. I know that Robin does and Mike does as well. Quite a few of us do. And this was one of our burning subjects that we really wanted to get across, because it's probably the most burning subject for us. It's prevalent in the current time that we are for COVID, about trying to get the message across and how theories and the thought process behind chlorination, pH values, and has really changed, and combined chlorine. So I'd like to sort of hand over to Ian if you can, and if you can manage to get this presentation going.
That's it.
Yeah, just hit present mode and you should be okay, I would have thought.
Yeah, yeah. Slideshow, go up to slideshow.
You are screen sharing presentation. No.
There you go. Well done, big guy. Well done. Well done.
On. Right, okay. Everybody listening, everybody can hear me?
Yes.
Yeah. Now, why we've opted to do one of these today, and as Robin and Ian have said, that we've done these on lots and lots of meetings throughout spring and summer, autumn last year, is that don't forget that until March last year, swimming pools are not used to closing down. They're 24-hour-a-day operations, 7 days a week, normally people in them 12, 14 hours a day, and so on. So when we started to close pools down last year, particularly Robin, Ian, Mike Schiff and myself, we were getting lots and lots of questions of how do we close it down, how do we open it up, and so on. So in between that, as you know, that PTAG started to issue technical notes, and I'm sure today's audience, you will have opened up most of those technical notes. But what it did do was that we started to use terms such as free chlorine, free active chlorine, free available chlorine, and so on. And it started to get people confused into what sort of levels we should be having within our pools. So what I've tried to do today is put an overview together, and please ask as many questions as you like, but put an overview together of what the terminology actually means and what it has shown, with most tutors being here today as well, from Institute of Swimming, Robbie from STA, Mike, Palm Academy, a few of us deal with all of those, is that perhaps we as tutors are not getting the message over in terms of students, learners understanding what we're actually trying to say. So if I may, pressing on now, is that the big thing that we still talk about in the UK is the chlorine level in pools. But with COVID, we need to open this up now and start to talk about pH in as much as the value that's got within chlorine. We know what pH is, and I'm sure the tutors amongst us explain in front of our learners the acid alkali structure, etc., 0 to 14, etc., etc., etc. But in terms of swimming pools, for too long, we've accepted that we need to drill our students into pH 7.4, pH 7.4, pH 7.4, and that's what it's been for a long period of time. Now, PTAG, we've taken the initiative, not just me, but the rest of the council members, that 4 or 5 years ago, we said, look, we've got to stop talking about pH 7.4. We're talking about 7 to 7.4, 7.2 to 7.4 being ideal. The one thing that we perhaps have not sort of highlighted is that if the pH drops below 7, it is not a Captain Mannering, we've got to panic. There is no need to panic. All we're suggesting is, as we say now, as you'll see in later slides, that we need to drop to pH 7. If it drops below pH 7, that is not a problem. If you think a lot of European countries that both Steve has mentioned this morning and Robbie's mentioned, is that a lot of European countries keep pH below 7 as a standard. So forget the COVID that we'll talk about in a moment or two. We're talking about pHs that are well below 7. 6.5, 6.8 would be a norm. Now, the problem we have is trying to educate and train, saying to people, there is no need to panic. Now, you will have seen log sheets, and I'm sure some of your log sheets may be the same, that printed on the log sheet, the pH is 7.2, 7.4. If it drops below 7, close the pool. If it goes above 7.6, close the pool. What we're saying now is there is no need to do that, because in line with Europe, I don't know, we've just pressed the button and exited Europe, that in line with Europe, we must be saying that it's not a problem. If we've got a pH of 6.8, it is not a problem at all. Now, on to COVID. Obviously, we know with the structure of COVID, as Robbie was saying with Legionella, we know that COVID is spread because part of the cell structure from the host is going to be implanted into the new host. In other words, an envelope virus. To maintain chlorine levels, okay, that's fine. But we've also got to look at the pH value for controlling the chlorine to kill the viruses, the bugs, and so on. Last on the slide means lowering pH for most of us because we're still working in this aura of pH 7.4. Now, to open up the reasons, we all know that when we add free chlorine to a swimming pool, that will give us the hypochlorous acid and the hypochlorite ion. This is something that perhaps we've not been very good at explaining to students in the past because all we get is free chlorine, free chlorine, free chlorine. What Ralph Riley opened up early on last year was a discussion of what the free available chlorine is. Now, we know that that's an Americanism for what we call free chlorine, but we've been too long now in just measuring free chlorine and accepting that that is the disinfectant in our pool. It is not. It is the hypochlorous acid that is the disinfectant in our pool. So we've got to take, as it says here, both into consideration. If the pH is higher than 7, then the predominant feature of our free chlorine is the hypochlorite ion. That is not a very good disinfectant. It is the hypochlorous acid that is the natural disinfectant. Now, believe it or not, we produce hypochlorous acid in the human body. And I'm sure, like other tutors listening in this afternoon, you take the human body where there is salt, there is water, and there is electricity. It is that produces hypochlorous acid in our cells. And that's got a pH of round about 4 to 6. And that's what helps us as human beings. If we get a cut or an infection, that's what helps to neutralize the bacteria trying to enter into our body. So you can see it's not a problem that we've got a pH of above 6 within a swimming pool, which will help to determine killing with hypochlorous acid. The hypochlorous acid itself, if the pH rises, as we've been saying a couple of slides ago, for instance, sodium hypochlorite, not that that's a bad disinfectant, but sodium hypochlorite itself has got a pH of around about 13, which is caustic, as we know. When we put that into a pool, effectively our pH might or even will rise. So we've got to bring the pH down by adding acid. And a lot of people say, yeah, but we might be adding too much acid to the pool and it drops below pH 7. Doesn't matter. If the pH is controlled to pH 7, the free chlorine, as we call it, the free active chlorine that we'll come onto, becomes more effective. So once again, we're not trying to measure an amount of free chlorine in the pool anymore. We're trying to measure the effectiveness of that free chlorine alongside the pH. Now, you and I know in STA manuals, in PALM manuals, iOS manuals, we always show the pH graph. So if I can take that and put it on board, scripping a slide first, this is now what we're talking about with active free chlorine on the graph that we're looking at. And if you look in the amber section, which is the pH, if we've got a pH of 8, the hypochlorous acid concentration is only 25% effective. So in effect, you've got a free chlorine level in your pool. Take the free chlorine level, you will see that that free chlorine level, whatever amount you've got, is only 25% effective. So that's what we need to look at in terms of. So we've got to start and say now, we've got to take this on board with our approach in terms of chlorinating our pools. We've got to control the pH. Okay, fine. We know we can do that because we've got automatic sensors, we've got automatic control units, then take it down. Now, if we can't get to pH 7, as we've published in the technical notes, it doesn't matter. What it means is that we, above pH 7 at 7.2, 7.4, we can adjust the free chlorine level so that the active free chlorine is still available to kill the bugs. Once we've achieved our pH value, as you know from PewTag, we've been saying at pH 7, if we've got a controlled bathing load, we can have anything over 0.5 milligrams per litre as a minimum if we're using a secondary disinfectant such as UV, as James excellently presented this morning. But don't forget, the free chlorine is only a measurement of the amount of the chlorine in the pool. It is not measuring the efficiency. So I've walked through reception areas where a manager has said to a lifeguard, what's the free chlorine level? 1.5, boss. Oh, brilliant. And then I'm saying to myself, hey, why is that manager not asking what the pH value is? We're just looking at the amount of chlorine in the pool. Now, what we've said within COVID-19, and on PewTag technical notes, this has definitely gone out to the industry, because when we feed back on it, that we've got to keep a minimum, an absolute minimum of 1.5 milligrams per litre of free chlorine has got to be kept in the pool at a pH of 7, because that will allow 78% of that free chlorine, of what we call active free chlorine that we come onto, to kill through the bacteria and through the envelope virus. This means checking our pool at different points, not just where the chlorine comes in, perhaps an old pool, 25-metre pool at the shallow end. So we must be, and I've said to my clients since reopening in July and then closing down again, reopening again, that we've got to check from perhaps the farthest away from where the free chlorine is entering the pool. It's got to be through the pool, not just at where the chlorine's applied. As the pH rises, the free chlorine concentration must rise in line with it. And once again, with the technical note from PewTag, that's what we've tried to achieve. And certainly, it's not a matter anymore of putting your set point at 1.5. It's the set point higher than that. Oh, sorry, come out of my share screen. Right. Now, back in. Now, what this means is that we've got to start now talk about active free chlorine. And for anybody around the table this afternoon, if you haven't been putting yourself up to date with PewTag, this is now TN60, and then we'll come on to TN61 in a moment. Now, TN60, as you can see here, if we've got a base pH level of 7, as we're trying to imply we should have this afternoon, then the free chlorine availability in there, the active free chlorine, 77%. And at pH 5, we've got literally 100% effective free chlorine. But we know in our pools we can't run at pH 5. But certainly, look at the German standards, for instance, as Robin mentioned earlier on. At a pH of 6.5, we've got a 91% kill rate at hypochlorous acid. So in other words, if you've got just 1 milligram per litre of free chlorine, 0.9 of that free chlorine is going towards killing bacteria. So we've got to start as tutors now to bring pH and chlorine into the same discussion, not just on separate sections on a course. Now, active free chlorine. Mike Schuff will bear me out on this, because he and I have worked very closely on this in the past 10 months. Active free chlorine is the part of the chlorine that people still don't understand. They say, well, look, we've put free chlorine into a pool. That's all we need to worry about. Active free chlorine is the element of free chlorine as tested by our DPD1 reagents of how well the chlorine is working within our pool. Now, we as tutors, and I know some people around the table this afternoon may not be tutors, but we've probably been the biggest culprits in this, because we've just followed the free chlorine. And certainly on some of my courses where we've done water testing workshops practically and looked at free chlorine. But how effective is that free chlorine? Well, you've seen from the graph on the previous slide. At a pH of 7, the active free chlorine will be approximately 77%. At a pH of 7.5, that drops dramatically to 49%. So less than half of your free chlorine at pH 7.5 is working. Once again, making it student friendly. Hey, a student earns £1,000 a month. Their mortgage is £500. So only £500, 50% of their wages, salary that's coming in is only available to spend, because the rest of it is tied up in the mortgage. So it follows, the lower we control the pH, the better disinfection we are going to get in a pool. Now, that's, I think, what we've got to get over and what we've got to work with. Now, it's only COVID and the problems that we've had in the last 10 months that's really put this to the fore. And certainly we need to make sure that in future, that when we're doing courses with STA, Palm, iOS, whoever, that the tutors have got to start and say, right, okay, we've got a level of chlorine in the pool, free chlorine, but this is the pH value. Now, Robin and I, only this morning, said, is it not in the future perhaps an issue where on our log sheets we have a third column? And I know Colin Jenkinson brought this up, I think at the last Palm meeting last year, is that instead of just putting free chlorine pH, is it not worth having a third column now saying this is the active free chlorine, because this is the important thing moving forward from now, not the amount of chlorine, but the active free chlorine that's working well in our pool. Now, we know lowering the pH has caused a lot of questions to be asked. In fact, Mike might want to come back to everybody on the chat with this, that even some manufacturers of components that fit in our pools have said, oh, we can't possibly drop a pH to pH 7. That will affect the warranty on lots of our equipment. No, it won't, because the pH at 7 is only neutral at there. So when you look at lowering the pH of pH 7, yeah, quite rightly, we might have to put other acids into our pool. Certainly, perhaps CO2 will not do the business to get it down to pH 7. Certainly, lowering pHs with the mineral acids, hydrochloric acid, sulfuric acid, might well start to lower and affect the alkalinity values, as a lot of you are already nodding around the table this afternoon. It might even affect TDS levels if we have to increase acid levels with hydrochloric acid, chlorides, and of course sulfates with sulfuric acid. We need to monitor these, and our latest technical note draft that Mike and I have been working on with PUTAG this week, as a matter of fact, is looking at how we can still balance pool water with lower pHs. It can be done. And as James was saying earlier on, with alkalinity, and as Stevie was saying, with alkalinity with calcium alpha chloride, 80 to 100, we can still just about manage pools, even if it's on a minus 0.2, 0.3 basis. PUTAG have said we can still balance the water if we look at chemical levels rather than looking at final numerical balances. Now, lots of the questions that I've had in the past 6-8 months have been, Ian, we can't possibly get our pH down to 7 because it won't balance the water. Now, a client of mine who's got a lot of leisure clubs up and down the country have not yet opened their spa pools, but they've asked the staff, the operatives, to look at the spas in terms of balance. Forget trying to balance a spa. At this moment in time, it's the pH value and the chlorine levels. And as you know, with TM47, that reopening spas, we've said that free chlorine should be at least 3 milligrams per litre in a spa. Now that will come later on, obviously, as we get to opening our spa pools. But I think what we've got to look at with the chemical consideration is first and foremost trying to get pHs down to pH 7 with a chlorine level minimum of 1.5, and that will give us at least 70, 79, 80% of that chlorine is working effectively. So it's not a matter of an amount of chlorine anymore, it's an amount of how active that chlorine is in our pool. So that's looking at the overview in terms of where we've been prior to COVID, since COVID, and certainly post-COVID. Because once again, I make no apologies for it this afternoon. Mike and I have been working very hard behind the scenes to try and put our organisation on a footing that when we start tutoring courses again, which looks big after March now, after yesterday's announcements, that we've got to start and say, right, okay, what we've done before, fine, but what we need to move on to now is looking at pH and chlorine as one subject area, not looking at pH in a morning session on a course, disinfection in the afternoon session, and not pairing the two together. I see a lot of people nodding, so obviously this is affecting them. Now, if we're looking at with COVID, post-COVID, the chlorine levels that we need to look at, then I think the next sort of discussion has got to be on breakpoint chlorination. Now, once again, what we've done in the past is certainly stand up in front of a class, a course, and say, right, we need to operate breakpoint chlorination. But what we should have been saying at the same time is it is only a theory, because certainly since the end of the first lockdown, people have come back to me, lots of people have come back to me via email, telephone calls and saying, look, we've got no combined chlorine. Well, you won't have anything close for 6 months. or very little combined chlorine. Now, the combined chlorine, as we know, comes from our bather. Okay, it will be from chemicals that we put into our pool, but predominantly it's from our bather, urine and sweat. And all three speakers so far today have mentioned temperature of water, the amount of bathing load, and Robbie went into great detail brilliantly in terms of biofilms, bathing loads, grease, and so on. We've got to look at breakpoint chlorination simply as a theory. You can see on the slide that we've always advised that free chlorine, so forget the active free chlorine for the time being, we've always advised that free chlorine should be at least twice the combined. But I think in that message that we've put over, we've misled perhaps students into thinking, oh, provided that the combined is only half the free, it doesn't really matter what it is. Now, PUTAG in the blue book, this particular version has said that on page 89, that the combined chlorine should be a maximum of 1 milligram per litre. But even that is being misunderstood, that we can go up to 1 with no problem at all. Well, TN61, that's in draft form at the moment, you'll be getting it once we've finalised it. This is looking at the combined chlorines because COVID, once again, has thrown up this problem of slavishly trying to follow numbers, as we've said on previous slides, with balanced water. So what we need to do now is look at breakpoint chlorination and perhaps lower the importance of this 2-to-1 residue, because it's pretty obvious that if we're allowing pools in the UK now post-COVID to go up to 1 milligram per litre of combined chlorine, thus looking at 2 milligrams per litre of free chlorine, I think it would be disastrous to keep on that leg, bearing in mind at pH 7. Now, in the past, once again, we have said that perhaps monochloramine, trichloramine have been formed at lower pH values. That's true. But once again, we should be saying now, is it dilution that we've got to start to look at in greater form? Is it, as James said this morning, we've got to install UV, which to me should be part of an architect's brief anyway, putting into new pools and putting into older pools as well. We've got to stop trying to chase it, which is why I've put this in capitals. PUTAG states that combined chlorine should never be more than 1 milligram per litre. But we are only our advisory group, guidances. We can't say to environmental health people, so yes, you've got to close the pool. We can only advise it. But it doesn't mean that because we've said it should not go more than 1, it doesn't mean it can go up to 1. That's a bit like Boris saying that we shouldn't be going out. We shouldn't be going out and sensible people will stay in, but people are still going out. So if it rises above this, we should be checking bathing loads, we should be checking dilution rates, turnover of pools, and so on and so forth. We should now be looking to get combined chlorines as low as possible. So what Ian and Robin asked me to look at this afternoon was the overview principles of free active chlorine, free available chlorine, if indeed we're going to call it that, and certainly free chlorine along with our pH values. That's what we should be looking at in terms of looking forward now to tutoring on our PPO courses, whichever organisation that we look towards. So just to recap, what I'm trying to say there is try and get the pHs down to pH 7 as near as we can. If we can't, okay, we explain to our students why that perhaps can't be done, as we said with CO2 as our pH corrector. Not just loading chlorine in for the sake of putting free chlorine. Oh, if it's 3.5, it's fine, because that may not be working, once again, if the pH is 7.5, as we've said. And it's getting students to understand the relationship between the pH value and the free chlorine level, in brackets active free chlorine, of how that disinfection is working in our pools. Now, I know other speakers have run over. I'm looking at my watch here, 25 minutes. But Robin, Ian, I think that's about where I need to be. And I'm sure this will evoke lots and lots of questions. So, with respect, over to you.
Brilliant, brilliant, Ian. Always a great presentation from you. Straight to the point, makes what would be perceived as a complicated bit of chemistry, and you make it into simple terms, which is great for me anyway.
Because I'm simple. Yeah.
But questions, guys, questions. Who's got, who would like to pose the first one?
I know it's the graveyard shift, the last one.
I've got a comment, Ian. I think that's
Yes, please
very
do.
good point there. I'm glad we're not going to be chasing this combined chlorine issue. But it's also worth highlighting, isn't it? I think that if pools are running at a lower pH, if they're using flocculation, the flocculation will also be much more effective at lower
Yes.
pH, as long as the alkalinity is you know, above.
Yeah.
Exactly. Now, sorry, not trying to butt in, and it's good to see you, Andrew. Sorry, after so many years. One of the trainers meetings I did, I think it was a couple of years ago now, the lads will tell me, for a palm, I actually did the experiment with PAC, because I like to do this in class as well. And what I did was just took a basic sample of water, 100 ml pool water, and put some PAC in it, and nothing happened. Nothing happened at all. But then I just sprinkled a little bit of sodium bicarbonate in, and it started to flock straight away. Now, okay, that was post-flocculation because we're probably not measuring the alkalinity, but you're perfectly right. I think the relationship has got to be that pH, particularly with aluminium-based flocculants, at a pH of 7, with an alkalinity of a minimum of 80 in our pool, 80 milligrams per litre, the flocculant will be working perfectly. And that's what we wanted to do, because not digressing, but the number of pools that you see, they've got their PAC, for instance, today, going in straight from their 25 litre tank, perfect. And they see it going in. They just presume, Andy, because it's going in the pool, they just presume it's working. Then you do a water analysis and you say, well, your PAC is going in, but it's not doing anything. That is an excellent point. Excellent point.
And if the flocculation's good, then there's every chance you'll be able to reduce the combined chlorine. So
exactly. Yeah, but I think we're guilty because, I mean, today it is about tutors. I think we've been guilty in the past, not derelict in our duties, but I think we've been guilty, perhaps not highlighting the fact of pH and disinfection working as it should. And COVID has allowed us. Now, Mike, I can't see his face, I can. Mike and I have done a lot of work on this, where clients have come back to us and they've simply been on a course and not understood this relationship of active free chlorine. Now, I know we all stress it. We're all going to say we stress it, and I'm sure we do. But I think this is just highlighted now of why we need to look at everything that we're doing in our pools and bringing them all into balance, not just one or two things.
Brilliant, Andrew.
If I can just come in there, Robin.
Yep.
You know, Ian, brilliant again, mate. I think the whole issue, I mean, you know, there's lots and lots of points in what Ian is saying. If I can just have 2 minutes just on one of them. You know, should we be replacing water test sheets and get rid of the free chlorine column and put active free chlorine or free available chlorine? From a personal point of view, I don't think that's going to happen. I think it'll remain as free chlorine because we've always referred to free chlorine since Adam was a lad. I think the important point, though, and as Ian quite rightly says, this is a pool plan trainers seminar. I think it's so important that the trainers understand this when it comes to passing the message over. Whether it's called active free chlorine, free active chlorine, available free chlorine, or whatever, it's critically important these days that trainers understand the association or the disassociation, if you like, between pH levels and the amount of disinfectant that's actually working.
Yeah.
I don't think we'll see changes to water test sheets, because if you do, you're going to have charts on the back of it to show how much of your free chlorine is actually working as a disinfectant when you've got a pH of 7.3 or 7.4 or 7.1 or whatever. But I think it's crucially important that trainers are understanding this and pass the message on during training sessions, you know, through discussion, through a manual, through the PowerPoint presentations or whatever, so that people do start thinking about what's behind the reading that they take, not just what the reading is.
Yeah, that's perfectly right, Mike. I think I share with you, perhaps on a log sheet it's not going to happen because even some younger managers today don't understand it, which is not a criticism at all.
Yes,
but
it is.
I think it's not. It can't, because the industry is changing so much. But at the same time, I think what we've got to try and do is say, okay, the days of just looking at free chlorine are now gone. COVID has proven that, and Putag stepped up to the mark by putting the TN sheets out. But I've just mentioned the TN61 as well, that we're bringing out next. That's actually saying to us, testing DPD1, DPD2, DPD3 for mono and dichloramines, because with this combined chlorine level, we're dropping free chlorine and active free chlorine. And for years, I know we've all said that if we look at free chlorine, total chlorine, combined chlorine, we should be looking at free chlorine. Okay, that's the number one. But now we've got to ask another question, as you quite rightly say, what is the free active chlorine? It follows that instead of just looking at combined chlorine, we've got to look now at what is monochloramine, what is dichloramine, how do we get rid of it? That's the important thing now. So I think you're quite right. We've got to take tutoring now to a different level, that the tutors need to understand exactly what they're putting across in class, so that the learners will take away that message, not just take away, we test for free chlorine. Now, I'm sorry, gang, ladies and gents, that's not a criticism at all. But this pandemic, this awful pandemic, has perhaps changed the way that we need to look at courses in the future.
I think we are now becoming more conscious about active free chlorine, and I think you're right, Ian. Over the last 10 months, I think it has had to come to the fore because of the changes that we've made to the guidelines. And for example, I've just received a wee message there from Dan, who's listening in. He has a software package that measures performance of swimming pool water test results. I think some of you might be aware of it, Pool Water TS. And he's got a section in there that actually puts the percentage of how well the chlorine is working. So that's that's great. That's an indication of the move, the change in the industry. And Andrew, going back probably 25 years ago, the old Stranco controller, the Redox one, I can't remember, was it the Stranco 4 that did both amperimetric and Redox?
Yes,
System 3, wasn't it?
Was it System 3? And and it used to do both the Redox and the amperimetric, and the top guys in the industry, the kind of real heavy duty charge hands and pool engineers used to swear by that because of the millivolt reading, because it showed you the relationship between pH and free chlorine. And it's almost as if we've kind of come full circle, you know, and now we're like, yeah, that's so important. Whereas the last maybe 10, probably 15, 20 years, it's kind of, it had died away till recently. And going back to what Mike said about the chart, I agree totally with Mike. I don't think we can change the log sheets. I would love to see that happen. But I remember seeing the charts for the millivolts and the relationship between the pH and the free chlorine. And it was very, very specific. You know, it went from like 6.8, 6.81, 6 point, you know, and it was so detailed. It was extremely detailed in it. And it showed you the performance of the chlorine. But, you know, so I do think we are moving in that direction. Because remember, last year, not last year, but the year before at the Putag conference, it was brought up, I can't remember, it might have been yourself, James, that brought up about pH. Why are we not aiming for a lower pH? And I don't know if you remember, Mike, I don't know if you were there, Ian, but Mike, you were there. And they said that, Janice said that we weren't going to go for a lower pH because we weren't able to measure it. The testing equipment wasn't good enough to measure it. And they didn't have faith in the industry achieving that level. Now they've had to, swallow that up and go for it. So we're now there. Let's kind of get to the next step, keep the conversation going, keep pushing, try and highlight it even more. And what we're doing today, and the tutors should be going out and saying, listen, do you know the impact of having a pH of 6.8? It is not scary. It is actually a positive. I would leave it. In fact, I would say it's even better than 7. That's what we need to get to. We need, because changing a culture is not easy. It takes all the little things you've got to keep moving, overcoming. And I think we're getting there, Ian. We just need to not let the momentum die. It has to keep going. It has to keep going. But we've got you and Mike on the Putag Council, so you can keep fighting the good fight.
If I can interrupt you there quite rudely, Robin,
Yeah.
I agree with you, but I would say, and this is not to patronize anybody, but I think it's everybody around this webinar today that will be the people that push this forward. You can have all the protocols, technical notes, etc., issued by anybody, but it's the people who actually talk to people who will push it forward and explain the reasoning behind these.
The understanding, yeah.
changes.
It's interesting to note that, you know, the German DIN standard insists that all pool controllers must measure redox voltage millivolts.
Yeah.
And it always must achieve a minimum millivoltage, and they control their dilution like that as well.
Yeah.
You can see when the urea levels build up in the pool, the millivolt drops off.
That's
even
right.
for the same free chlorine.
Yeah.
So as the millivolt begins to drop off, they know it's time to reintroduce some fresh water and bring the urea levels down. So that's really interesting.
I mean, not to sort of go back in time. I wouldn't want to do that. But at the same time, when we have the system 3s and the system 4s, just a bit of education, was that you had the millivolt reading in the centre, and you had a derived free chlorine level. The problem was that in the UK, and it was only a simple problem, nobody would follow the millivolt reading. But when you looked at it, if you monitored it and the pH started to rise, the millivolt reading would fall, but the free chlorine level stayed the same. And that was the problem. When the green light came on, everybody thought, it's got 1.5, no problem. But the pH, if you like, was trying to shove the chlorine uphill, because they said, we need to increase the chlorine level. Well, no, drop the pH level. Now I'm pleased to say that instead of trying to raise the chlorine level, we are now beginning to follow the Europeans and drop the pH value, which is excellent news. Excellent news.
Yeah, it's almost come full circle, isn't it? Because I can remember the Strantrol 3 system. Now there's very few of the new control panels which register millivolt patterns, but as you say, the way to control it is to bring the pH down. So hopefully we will achieve the same purpose, but maybe from a different angle, and that's focusing on pH. Some of you might know, actually it's 12 months ago. 12 months ago now, I was actually commissioned to do a lot of survey work in Europe. I actually drove back on the day before Europe locked down. Some of you might think it would have been better if I'd stayed there. I would have been stuck over there for a bit. But of all the places I went to, all the places, Belgium, Holland, and Germany, I didn't see a number 7 in their pH readings. They all started with 6. 6.8, 6.9. Pools are absolutely fabulous.
We've got to change our culture. That's what it's all about. Changing the culture.
And I think. But maybe it was yourself, Ian. I can't recall. It's an age thing. When you're saying about, does bringing the pH down affect equipment? Well, bring the pH down to where water is neutral. Yeah. Okay. And when it was dropped down to the advice came out 7 to 7.4, ideally 7 to 7.2. I did have a number of people call me and said, "Oh, we're going to get warranties voided on this, and systems are going to collapse all over the place." No, the majority of warranties state that this piece of equipment will operate to PUTAG guidelines. Well, okay, the guidelines have changed. Okay, at 7.0 to 7.4, there shouldn't be any adverse effect on equipment whatsoever.
No, I mean, a lot of the leads come from America, obviously, and the Americans will nuke anything with chlorine.
Yes.
Sorry, the Americans will nuke anything in the world, but they'll nuke anything with chlorine. But even now, the Americans have started to say, and if you read the blue book as we do, obviously as tutors, on page 89, it does say at the top of the first column that even the Americans now are recognizing that lower pHs means you don't have to put as much chlorine in to get the same effect. So even the Americans are coming around to low chlorine levels, low pH levels. Yeah.
Brilliant. Any further questions, guys, while we've got our experts in the room or on the screen?
What, you want more questions at 3:10 on a Thursday afternoon?
Right.
Yeah,
I get the message. Mike needs to get home.